Hello, everyone. As I have started a new YouTube channel where I'll be discussing on network security and cloud related certifications and some basic topics on network security and cloud. So today we are going to see OSI model. OSI model cannot get simpler than this one. So I'm going to show you what's happening at the back end. So let's assume this is my computer. I have made this diagram so it will be easy for me to explain what's happening at the back end. So right now I am sitting on my computer. This is my computer. So on my computer, I have three types of addresses. So one is a MAC address, which I have mentioned here as MA. So on a switch on every port, there's a MAC address. So I've just given two MAC addresses because I'm connecting my PC to a switch. Switch is connected to a router. On the router also, there is a MAC address on every port. So I'm giving two MAC addresses here. And then there's a Google server. On the Google server, I'm also giving a MAC address because it's also a computer. So here, I also have an IP address. So there are two ways to give IP address to my computer. Either I can give static IP address or I can use DHCP, Dynamic Host Configuration Protocol. So which is going to automatically assign IP address to my computer and some other settings like subnet mask default gateway. So I will show you what's the use of subnet mask, what's the use of default gateway. But right now, there are three addresses given to my PC. One is my IP address. So this is my IP address, which is type C network. If we talk about IPv4 dot decimal notation, I also have this thing which I call port address. So if I talk about ports, there is a port which starts from 0 till 65535. So 0 till 1023 is well-known ports. 1024 till 49151, these are registered ports like RDP port, which 3384. You can use it. You need to get registered, and these ports are getting generated from the range starting from 49151 till 65535. So I assume I am generating a port here. So when do you generate a port? This is your source port. So when you generate a port, when I am trying to open any website, so let's assume here I am trying to connect with a Google. So let's assume this is my Google. So here I am trying to open Google. In other tab, let's assume I am opening YouTube. So when I try to open Google, I type www.google.com. I tell to my computer, please get me a Google page. So that's what I mean, www.google.com. So what happens, let's assume here, I will show you how I interact with Google. So in my computer, I'm opening two websites. One is Google and one is YouTube. So it will be generating two source ports in the range of maybe let's 50,000 or other one is 51,000. So when I tell my computer www.google.com, I'm asking it, please get me Google page. So it will go to the DNS. It will ask DNS, Mr. DNS, do you know what is this google.com? So DNS will get the IP address of Google. It will keep that in cache, but I'll not go in detail in DNS. But here I'm asking simply to DNS. My computer is going to ask DNS, do you know what is google.com? DNS will say, yes, that is 172.168.9.3. Now my computer knows that my IP address is this, and I have to get a destination IP address this. So is the destination address in the same network? Then I will give this message to a switch. If it is in a different network, then I will give it to a default gateway, or I will give it to a router, which is my default gateway. So now what will happen here? It knows that destination is in a different network, so it will give it to a default gateway. Otherwise, if Google was in my network, it would be connected here. Then I will give a message to switch. Switch is going to give it to Google, and I'm going to get reply. But here, Google is somewhere else. Now my computer knows. So what is going to help my computer to make this decision? That is my subnet mask. So that is the reason you have a subnet mask, because subnet mask is going to tell my computer whether destination is in a same network or in a different network. Now this is the second decision. So this was the first decision with DNS, and second decision comes with subnet mask. Now my computer is going to send this message to router, but it needs to send a frame, because here I'm going to show you how OSI model is going to come in picture. So if you check OSI model, it's a reference model. Now I'm concerned with physical data network transport, because if you see session presentation application, there's a 7 layers of OSI model. We already have TCP/IP model, which is working in our computers because it was started by Department of Defense. There are 4 layers. but this also you can take as a reference model. There are a lot of reasons why OSI model come in, but the main reason was, you can troubleshoot your networks, or you can also follow standard. So if you need to design a switch which works in a data layer, you can follow some standards. So there is no compatibility issues which a user can face. Otherwise, earlier, if you see, if you buy a laptop from IBM, you also needed to buy pen drive or other devices from the same company. So that was a big headache. So that is the reason, if you follow OSI model, all the organizations, they come up with a particular standard. So I'm concerned with physical, data, network, and transport. So if you see at the transport layer, this is what I call segment, because this segment will have the port address. So it is going to make a segment which will have port address. Then at the network layer, it's a packet which has IP address. At the data layer, it's a frame which has the MAC address. So these three addresses are very important. That is where spoofing can happen. There can be port spoofing, IP spoofing, and MAC spoofing. So what happens here, if you see a segment, so this is a segment. So it is going to add a port information. I'm coming from 50K and I want to go to 80, because on the Google, there might be a lot of services running. So there could be 25 service, which is for your email, or there could be an HTTPS service, or HTTP, sorry, this is for your web server, or HTTPS 445. So I assume I'm running this server on port 80. Now it's going to create a segment which has a port information. Segment will get encapsulated into packet. So this is what happens, the OSI model is doing encapsulation. So segment will be put inside packet. Packet has the IP information. I'm coming from 2.3. So this is my 2.3, and I want to go to 9.3. And then the frame information. I'm coming from MA. I want to go to MD. So I'm coming from MA. Now, what will happen here? There's another protocol which is coming in picture. That's ARP. So my PC knows that 2.1 is a default gateway. So it will say to switch, whoever is 2.1 in your network, please send me your MAC address. So my router will say, oh, it is me. Let me send you my MAC address. Then it is going to attach this MAC. Now this complete frame will come to router. But the default behavior is that switch understands MAC address, router understands IP address. So that is the reason, this ARP is happening, because it needs to be sent as a frame. So switch can understand it. Now what happens, this frame is coming to router, but router does not understand what a frame is. So what router is going to do, it is going to open the frame. Then it will see, oh, this is coming from 2.3 and it has to go to 9.3. Then what it will do, it will create a new frame. Now the source will be ME and the destination will be MF. Now, why did router open this frame? So that it is going to see from where is it coming, where is it going, because router is concerned with what's the best path. So it's going to choose path. It is coming from my PC, Sheikh's PC, and it has to go to Google. So it will check what's the best path to reach to Google. Routers care about networks and the best way to reach them. Switches care about hosts and how they are connected. So what will happen here is going to receive this frame. Now Google will check, oh, this is a frame coming for me. It's going to open. Okay. Now with the help of MAC address, it will think that router has sent it. So it is the IP address which is going to send the data from the right computer, okay, from the source PC to the destination PC. So the frame which has helped the packet to go from node to node. So node to node delivery happens at the data link layer. Switch understands MAC address, switch works here. This is what we call frame. But the actual communication happens through the IP address from source computer to destination computer. That happens at the network layer with the help of IP address. So IP address takes a packet from source computer to destination computer. Now here, Google is going to open it. It will say, oh, this is coming for this port, not for this port. So this is actual communication, which is process to process communication, which happens with the help of port numbers, which happens at the transport layer. So that is what we call segment. So these are port numbers. That is the reason we use port numbers. Now this port number along with the IP address is also sometimes, we call it socket. So it's a socket which takes data from right PC source to destination. So now it's going to open it. Now the reply is going to come. Now what will be the reply? So it is again going to do the same process. It's going to make a frame with source of MF. Now the source will be MF and the destination will be ME. Now router is going to open it. It will say, oh, this is coming from Google. It has to go to Sheikh's PC. It will just create a new frame. Now the source will be MD. And for the destination, it will again do ARP. Whoever is 2.1, please send me a MAC. my PC will say, oh, this is me, let me send you a MAC. So this is where MAC spoofing can happen. Someone can pretend to be, some other MAC. So how they do that, since they cannot change MAC address because it is written in your hardware, so they use a software which is going to show a different MAC. So that's where spoofing can happen, MAC spoofing. Or you can also do IP spoofing, you can do port spoofing with the help of a lot of tools like hping-free and all that. It's very easy. MAC changer in Kali. So what will happen now, it reaches here. Now it will do again MAC, it will again do ARP, packet reaches here, it's going to open. Now my PC is going to say, oh, this is for me, and it has to go to 50K. So that's where source port is very important. So message comes to the right process on the right computer. Source port, destination port. So that's where, port number will be generated. So you can check that also with the help of Wireshark. So this is it about OSI model. This was like a brief introduction on what's happening at the back end. So I am going to come up with some other topics, very interesting, where we are going to go in deep. I don't think, OSI model can get simpler than this, because we have already read it in our college, where it's very difficult to understand. But with this example, I hope this is clear. If there's any comments on this, please do let me know. Thank you very much. I'll come up with some other video.